right, in this video, we're going to talk about solving or creating and solving exponential equations. All right, so there's two different types of exponential equations. There's an exponential growth, which is of the form y equals a times 1 plus r to the x power. It is a power of x, where a decay is of the form y equals a times 1 minus r to the power of x. So the 1 plus r would mean that this b value on the inside is greater than 1, which is a growth. The 1 minus r would make this b value inside the parentheses less than 1, which is a decay. Now let's talk about what each of these parts represent. So the a value is going to be the start. Your R value is your rate as a decimal. And the X is time. All right, so just a quick review on converting. Since we are dealing with rates as decimals, we want to make sure that we can convert a percent to a decimal. Anytime you want to do that, it's just dividing that percent by 100 or moving your decimal 2 places to the left. So notice 38%. If you take 38 and divide it by 100, that gives you a 0.38. So here we would have 0.38. Same with the 7%. If you want to change 7% to a decimal, that's 7 divided by 100, which is 0.07. 5.9%. If we wanted to convert that to a decimal, we would just take that 5.9 and divide it by 100, which is 0.059. And the last one here, if we're going to convert 22.6% to a decimal, we're going to divide that by 100, and that's 0.226. All right, now that we have that information, let's actually look at some examples on creating exponential equations. So number 1 says the population of Hillville is 5,000 people, and it grows at an annual rate of 15%. Create an equation to represent the population of Hillville for any given value of x. So here's what I do every single time I'm solving these equations. I identify each of these parts, a, r, and x, and then I make my equation. So your a here is your start value. So Hillville started with 5,000. Your R is your percent as a decimal. So notice I'm given 15%. We can take that 15 and divide it by 100 to see what that value is as a decimal. So 15 divided by 100, that means our R value is going to be 0.15. And x we don't know. So what we are going to do here is plug each of those values into our growth equation. So it does say it's growing at a rate of 15%. So if I have my growth, which is y equals a times 1 plus r to the x power, I need to plug each of these values into their correct spot. So I'm going to have y equals, our a was 5,000, 1 plus our r was 0.15, and then to the power of x. Now, if I'm looking at my answer choices, I don't really see that plus, which means what's inside the parentheses has been simplified. So if you want to see what that is simplified, you can add that together in decimals or a calculator, and I get 1.15. So this equation really, oh goodness, is y equals 5,000 times 1.15 to the power of x. So that would be a. Okay. All right, next one. We have example number 2 here. It says your grandma bought $30,000 worth of stocks. The economy went into a recession and she lost 11% per year. Create an equation to represent the value of grandma's stocks as a function of years. So same thing as the other example, I always identify A, the start, and this A is 30,000. And then I represent my R. My R is 11%, but that is a decimal of 0.11. Now this does say she lost money, so you should use the decay equation. So that's y equals A times 1 minus R to the x power. Now that I know each of these parts, I'm going to take this 30,000 and plug it in for A, and the 0.11 and plug it in for R. So my equation really should be y equals 30,000, 1 minus 0.11 to the power of x. Now, if you're looking at your answer choices, none of those really look exactly like the equation that I have here. So what we could do is take this b value and simplify it. What is 1 minus 0.11? Well, that is 0.89. So what should be in the parentheses is 0.89. So that looks like D here. D would be our answer. All right, we have 2 more examples. Suppose you have $300. You invest this money into an account earning 6% interest each month. Write an equation to model the scenario. So identify the start. The start is 300. And identify your R. Your R is 6%, but that is a decimal of 0.06. And we are looking at a growth function. It does say it's earning money. So we would do A times 1 plus R to the power of X. Since it's growing, that value on the inside should be greater than 1. So you can definitely eliminate B here. All right, so let's plug in what we know. Y equals 300. 1 plus my R is 0.06 to the power of X. Sorry, I keep hitting the wrong button. Now, if I add that together, that would not be A. So let's see what the other answer choices are. We should pick, don't pick D because that's a decay. We're going to pick C because if I take 1 plus 0.06, that will simplify to what's inside the parentheses of C here. Last example, the initial number of bacteria in a petri dish is 200. That means my A is 200, that's my start, and is decaying at a rate of 15% each hour. So my R here is 0.15. And now I want to plug in everything into the correct spot for the decay. So the decay is the start, 200, and then 1 minus your R value, and then to the power of X. So if you're looking at your answer choices, they each have the correct start of 200, but if I want 1 minus 0.15, I need to figure out what that is inside the parentheses. So that would be 1 minus, it was 0.15, which is 0.85 is what should be inside the parentheses here. So that would be A. Those were your 4 examples on creating equations for exponential equations.